Grazie, se mi vuole, scusi. Okay, good morning. Good morning to everybody. Some participants are still connecting
Good
on the
morning, sir.
process of connection. And welcome. I'm Alfredo Milani. I'm the chair of this section, EW, International Workshop on Collecting Evolutionary Systems. And I'm glad to announce this is the 10th edition of this workshop. So we really enjoy to have such a long tradition. And I also welcome Dr. Rajdeep Niyoji, which I see is connected. I have also some physical public. We can show, I don't know if we can show public in the room. You can see it's very magic, like magic. Okay. No, never mind. Ok. Sì, rimettiamo, scusatelo, in diretta perché sennò. Okay, thank you. So we will show you the room later. This is a COVID time for everybody in the world and in Italy too. So we have a few physical participants, but it's very important that we start back to physical conference, okay? So I'm glad to introduce the first speaker of this morning that I guess is Amarnath, is it?
Yes, sir.
Yes, thanks. And the first paper, which is going to be presented as a title, Distributed Framework for Task Execution with Quantitative Skills. Authors are Amarnath, Dr. Rajdeep Niyoji from
Hello, Alfredo.
Indian Institute of Technology. So we can, Amar, we can hear you, I guess. Yes?
Yes, sir.
And you can share the slides and start whenever you like. Thank you.
Sir, is my PPT is visible?
Yes.
Good morning, sir. Good morning to all listeners that are listening physically as well as online. My
Yes.
topic for the presentation is distributed framework for task execution with quantitative skill. The work is done by me and my PhD supervisor, Professor Rajdeep Niyogi, professor at IIT Roorkee, and myself working with Slight, deemed to be University, Longowal, Punjab, India. The outline of my work is introduction, problem, scenario, then related work. Then I will discuss the formal framework for task execution, and then distributed approach for task execution. And subsequently, I am going to discuss about the experiment setup and the results that we obtain. And then finally, I'm going to conclude my work and some future work. Introduction. If we see in current scenario, collaboration execution, task execution is an important area of research in multi-agent systems. In some situations, the agents are spatially distributed, have limited information about the environment, and update their knowledge via exchange of messages. To execute a collaborative task successfully, robot may need to be present at the location of the task where the task is located. However, the required number of robots may not be present at the location of the task. As earlier I mentioned, the robots or the agents may be distributed spatially. A distributed approach has been proposed for such task execution in the literature in paper 1 and 2. In these process, skill of the robot required for the task execution are represented as a p-dimensional binary skill vectors. However, if we see in the real world application or scenario, it would be more desirable to consider real valued skill rather than having present or absent of the skill that we present in the binary form. But here we have to give some values, like if we want to see ki push skill is required, but we have to again see the value, what should be the value, like 20, 10, or in that manner. In this paper, we developed a distributed framework that considered quantitative representation of these skills. We have performed extensive experiment on a RoboCup rescue simulation environment. The experiment that we obtained saw the efficacy of the approach. Now, let us discuss the problem scenario. In this paper, task execution is done in a particular observable environment where the agents are spatially distributed and no agent has a global snapshot or the global knowledge or global view of the environment. Thus, complete knowledge of the world is not known in advance. It can be determined partially when the need for the coalition formation arises at the runtime. In such situation, no guarantee can be given that any previous found coalition will execute the task execution. Let us take the snapshot of the environment. We have taken the snapshot of the environment at time t, t2, t3, and t4. If we see in first scenario, or the snapshot that is taken at time t1, if we see in the environment at time t1, there are two tasks, tau1 and tau2, and number of robots that are available at different place of a grid, robot 1 to 4. Again, the snapshot of the scenario of the environment is taken at time t2. So where we found that the number of robots are increased, means the number of robots presented in the environment in that particular environment are 5. It means in between that one extra robot has been entered into the environment. So that creates the dynamicity. Or if we see robot 1 has detected the task tau1 and robot 4 has detected the task t2. Then the main goal of the framework or the algorithm that we have designed is that the number of robots that are required to execute the task must gather at the location of the task. So in scenario that we have taken at time t3, we see the required number of the robots have reached to the location of the task. And finally, the snapshot that is taken at time t4, we see that the task has been completed and the boxes that we see at A location and G location are finally shifted to the desirable location. So in that way, this scenario shows how the work is identified, then how the number of robots required for task execution are gathered with the help of the algorithm that we propose, and finally the task is executed. If we see some of the relevant paper that we took as in related work, the work 2 to 5 that is given there. So consider collaborative task execution in a dynamic environment where all the agents associated with execution should be present at the location of the task. Distributed approaches for collaborative task execution are suggested based on different assumptions. Team size is known in advance, and each agent in a team should have a set of skill that is superset of a skill of the task. Whereas in paper number 4 and 5, consider p-dimensional binary skill. This paper that we are presenting today consider a more general p-dimensional skill vector where each element can be a non-negative real number. Such a representation of a skill of a robot and task has been considered in paper number 6. And in 6, a coalition problem is considered such that there is no coalition imbalance, which informally refer to the degree of dependence on some member of a coalition. The notation of the imbalance is beyond the scope of this our paper. Now, let us discuss about the formal framework for task execution in an environment where the skill of the agent as well as the task is, some real number rather than the binary things. The intention behind the following definition is to capture the dynamic nature of the robot, number of robots present in the environment, and the location of the robot change with the time. Dynamic nature of a task, number of tasks, the environment, and the location of the task change with time. Means the task may be arrive at any location What it means? It means that when the robot are searching for the task may be found at any location of the environment. Moreover, this dynamic nature of the robot and task is not known in advance. In advance, we don't know, because as we already discussed, the agent don't have the global snapshot or global knowledge of the environment. They have just a partial knowledge, the knowledge of the nearby environment. Now, the robot that we have defined in our this particular work can be defined as a 10 tuple where ID, its unique identifier, S is the subset of skills, state from among a possible non-empty finite set of S. Then psi is a capability vector represented by capability, and mu is the location mapping from one to another to represent mobility. M send, M receive are the set of messages that represent the message sent and received. Then Boolean B represent the whether the a particular robot is present in the environment or not. And L is the location, and theta and theta prime denotes the remaining battery, because we have taken a battery as a main concern of a robot, because if the battery is down or battery gets down, then a robot cannot work in the environment. Theta dash represent the battery consumption rate respectively of the robot, because a robot have to move in the environment. And what we have assumed that a different robot that have the different capability, they may have the different power consumption, because the power consumption also depend on the weight or some other aspect of the robot. A robot with higher theta ensure means if the remaining battery is higher, ensure that it will not fail due to the more remaining battery, because it had the more battery, so it will not going to fail in between the task execution. A robot with lower theta ensure that it will last for a longer period of time. So these are the different parameters that we have assigned with the robot. If we see the capability vector, the definition of capability vector is that a p-dimensional capability vector V is denoted as a V alpha 1 to alpha p, where alpha I is a non-negative real number to give a quantitative representation of a particular capability. If we see one example here, if we say the capability of a robot R1 is psi R1, then 30.5, 0 and 0. If the skill of another robot psi 2, 0, 20, 0, it means the holding, pushing have the different capability, and they are the real numbers instead of just 0 and 1, because 0 and 1 just represent whether the particular skill is there or not, only the presence. But to represent the capability, we have to use the some real numbers. So same has been shown in a table number 1, capability vector of the robot. Capability vector operators, obviously these are the important operators that we have defined in our work. Let V and V2 be two p-dimensional capability vectors. V1 where V1 is alpha 1 to alpha p, and V2 is beta 1 to beta p, where alpha and the beta p are the capability represented by the non-negative real numbers. Let Vji denotes the ith component of Vj, that is alpha I or beta I. We denote the following operator on the capability vector such that V1 equal to V2. What it means? It means that it will return true if and only if for all of I 1 to like p 1 to p, V1 I equal to V2 I, means the position for all position alpha I to alpha p, each and every element is equal. If we see another operator, V1 earth V2 equals true if and only if there exists I such that V2I is greater than 0, means it has some values, and V2I is again greater than 0. It means there is a requirement of a skill, and V1 has some skill that is present there. It means a robot that has satisfy this condition, it means it is going to be the part of a team. It may be the part of the team. It will depend upon the algorithm after run. V1 sun V2 equals to if and only if there exists I, V2I is greater than 0 and V1I greater than or equal to V2I, means all the subset of the skill that is there is greater than or equal to V2. Two vectors are equal if all the corresponding component of the vectors are equals. So this is the thing that we have defined. Now if we take the example, so let V1 20 0 12, V2 5 2 8. It is easy to see that V1 and V2 are not equal because each individual value are not equal. V1 earth V2 is true since for the first component of the values 20, 5 and 5 respectively, which exceeds 0. V1 sun V2 is not true. The first component of V2 is 5, which is greater than 0, and the first component of V1 is 20, which is greater than 5. The same is true for the third component. However, for the second component, the value of V2 is 2. Here, V2 is 2, which is greater than 0, but the value of V1 is less than 2. Necessary and sufficient condition for the task execution. So let V1 and V2 be t-dimensional capability vector of a robot and a task tau respectively. If V1 or V2 is true, it means that the robot can participate in the task because it has some skills that is required for the task. V1 sun V2 is true if the sufficient condition for the robot to execute the task is there. Now let us define the task. A task tau is specified by a 4 vector V, L, T, psi, where V is the name of a task like move, carry, box, B to location L, prime, lift disk D, L location L prime, tau T is the location where the task arrives. T is the time at which the task arrives, and psi is the t-dimensional capability vector required to execute the task.
I'm sorry, Amar.
Yes, sir.
This is Alfredo Milani. I would like to ask you to do not say too much on the details.
Okay, sir. Okay, sir.
Go ahead, because we have a very tight schedule online, and we are.
So this is the framework. The different definitions are given, and even the listener can find out these definition in the paper that is there, even available online. So cost, how we have defined the cost, domain correlation. Now let us discuss about the distributed approach for the task execution. The thing is that there is a distributed algorithm that we have defined in which each and every robot has the same priority, and the robot who find the task start the coalition formation, and whenever the task is identified by a robot, it becomes an initiator, and rest of the robot are considered as a non-initiator robot. If the condition that we discuss about when a coalition can execute the task is get successful, then the initiator call the robot that are in the coalition, and the robot that are there that are selected come to the location of the task, and task get executed. If the coalition is not get successfully formed, then the robot at that time leave the task and search for the another task. So this is the algorithm. Now if we see about the experiments and the results, for the experiment purpose we have used the Argos, a multi-robot simulator, and we have used a simple Ubuntu machine to run our experiment. If we see why we have used the Argos, even some VRAP or ROS Gazebo robot simulator are also there. But the thing is that the requirement of our work was that we have to send the message, receive the message, and we have to modify some of the things to get our experiment executed. For that, Argos was best fitted. That's why we have used the this particular Argos algorithm. Then road clearance environment we have taken, and we have taken the different robots and different tasks, and the capability of the task is defined like this, like large disk for task 1, large box for task 2, small disk for task 3 and task 4. And this is the snapshot of the environment, how the robots and the tasks are distributed, and they are at different places. Road is there, and the goal is to shift the these tasks or boxes side by the road, and robots have these skills and capability and theta that are presented here in the table. And now task execution scenario is shown here, robot 3 and robot 4 detects tasks T1 and T2 respectively and form their coalition. And this is the results, how the different robot have identified the task, what robot have identified which task is on, and what is the coalition, ultimate coalition, and the cost is given. The thing is that because this is the coalition is defined at the runtime, so that's why we cannot say the same type of the task can be done by the same number of group, because at different time different robot might be free and different robot team of robot or coalition of the robot execute the task, and even cost might be a different one. So this is the conclusion from the scenario. In this paper, if we conclude our work, in this paper we consider collaborative task execution in a dynamic environment where the location and the time of the task arrival, the number of robot, location of the robot are not known in the advance. A formal framework for cooperation task execution is provided. The distributed approach suggested in this paper considered quantitative representation of the capability, and so it generalized previous work that considered binary representation of the capability. A RoboCup rescue simulation environment is taken for the implementation and distributed approach using Argos. Several experiments were carried out. The results are quite encouraging, and it demonstrates how robots are executed the task, and that different coalition are formed in a different simulation run for the same task. Implementation of the distributed framework is quite challenging, and that is a part of our future work. We want to transfer this work to a real world scenario. This is our future work. These some of the references. Now, thank you from my side. If some queries there, I will be happy to answer.
Okay. Thank you very much, Ahmad. Is there any question for the public? No. I have a question, actually. It's very interesting, the mechanism of a coalition formation, and I would like to ask you two things on this aspect. First of all, is our coalition partition? I mean, if one robot can take part to two different coalitions?
Yes, sir.
In the same session? Yes. And the second one is that if a coalition are for the whole task, I mean, or they can change during the same session, let's say, the same experiment. Or once a coalition is formed, it will last until the end of the whole simulation.
Sir, the thing is that what we have considered is that at the time of coalition formation, different state of the robot are considered. Like when a robot identify a task, it changes its state from like idle to the ready state, and it sends the messages. And when the messages are received by the other robot, only the robot that are in the idle state responds. If the robot are in some other state, like the promise state or some busy state, they cannot send the reply back to the sender. They just ignore the messages. It means at a time only the idle robot, those are free, only participate and only reply back to the initiator. Another question is that at a time, if a robot is engaged in one task execution, the robot cannot left the task in between, because the state of the robot, what we have considered, is busy. Because in busy state, it is not going to respond to the other, robot. So this is the thing that we have considered. After execution, it changes its state to the idle, and if some request is there, then it responds back to the other robot.
Okay, thank you very much, Emma.
Thank you, sir. Thank you.
I think we can thank you, to Dr. Rajdeep Niyogi, Professor Niyogi. I think it's time to go to the next speaker, which is Giulio Biondi from University of Perugia, as a co-author Valentina Franzoni and Alfredo Milani, is going to present a talk on parsing tools for Italian phraseological units. So please, Giulio, you can start when you like. Ti vediamo.
Ok, un secondo che lo condividiamo.
Vuoi venire seduto dove sono io? Qui. Come ti pare?
Okay, good morning everybody. I'm Giulio Biondi, and today I will talk about parsing tools for Italian phraseological units. Phraseological complexity is a concept which is paramount in assessing the language proficiency of students who are learning Italian or any other language as a second language, and is an important concept also when performing automated text analysis for automatic assessment of the production of second language learning student. Although it's an important concept, there is no definition available in literature on which academics are reading. Okay. Attempts to give a definition of phraseological complexity are based on the following one: a matter of the number and variety of an item's constituent elements and of the elaborateness of their interrelational structure. So this definition was given by Rescher, and basing on such definition, the existing attempts to define the phraseological complexity of a text draw on lexical diversity measures, such as GIRO, MTLD, or the syntactical complexity of a sentence, of a text. So the mean length utterance and the amount of subordinates in a text. In other works, also the pointwise mutual information measure was used to measure the complexity of a text. In any case, it is fundamental for the task of defining the phraseological complexity to have natural language processing tools which can be used to analyze a text and perform various tasks. The most common tasks in natural language processing, which every toolkit should have, are the following ones. So a toolkit should be able to tokenize a text, breaking it into its constituent, to segment a long text into sentences, to perform morphological analysis of a token in order to split it when it's composed by more than one part. Then lemmatization, so reconducting a word to its base form, for example, where there are variations on a verb. Parts of speech tagging, assigning to each token a tag describing its role. And then named entity recognition to identify, for example, proper names or city names in the text, and entity linking, which is more advanced than named entity recognition, in the sense that after identifying such entities, it can link it to other sources of information, speaking about the concept which has been found in the text. The point is that NLP tools must be language specific, because every language has some specific patterns or specific rules which need to be taken into account while developing libraries working on text in that language. In literature, of course, English plays the main role. Much of the efforts in natural language processing have been dedicated to analyzing English text, but tools are becoming more and more available also in other languages. And for this work, we focused on Italian language. So now we are going to see the 3 tools we considered for this work. The first one is TINT, the Italian NLP tool, which has been developed at the Foundation Bruno Kessler. And it's based on the popular Core NLP API developed at the Stanford University, which is originally available in 6 languages. And for this purpose, at FBK, they developed a custom Italian tokenizer and morphological analyzer, which were integrated into the Core NLP API to form TINT. It's available in the Java language and also as a REST API, and it's extensible with more custom models. The second tool is UDPipe, which was developed at the Charles University in Czech Republic and is based on the Universal Dependencies Framework, a common framework which is used to provide annotated text in many languages. For this reason, UDPipe is language agnostic in the sense that it can be trained with different language corpora. For Italian language, there are 5 models already available trained to use, and there are many bindings available for different languages, most notably C++ and Python. The third one is Spacey, which has multi-language support. It has 3 already trained Italian pipelines. It has custom deep learning models which can be trained and is available as a Python library. Here we present a functionality comparison for the 3 toolkits. So all of them offer the basic functionalities we were speaking about before, although the basic functionalities for UDPipe are offered in different versions of the toolkit. So some are already in development and will be available with the 3rd release, while for TINT and Spacey, all of them are available already. Here we present a sample sentence. Our experiments were performed on a corpus of texts for Italian L2 learners. And this sample sentence means if we watch TV, read a newspaper, or surf the internet, we are constantly presented with advertisements for various products. So here we show the visual output of the UDPipe framework in analyzing the sentence. The structure is clearly readable and highlights the dependencies between the words by putting them at different levels in the tree. And here we have the visual output of Spacey on the top and TINT on the bottom. Both of them stretch horizontally, and while the TINT visualization is more informative since it has also colors highlighting the different parts of speech. Here we focus on a part of the sentence where we can highlight an error which is made by Spacey in identifying the constituent of the sentence. So the part vengono continuamente proposte is identified by TINT and UDPipe correctly, since vengono is the auxiliary verb for the word proposte to form the past time of the verb. And these 2 toolkits identify correctly vengono as an auxiliary and proposte as the main verb. while Spacey identifies proposte as a noun, because proposte in the Italian language means proposals. So this is an error, and we identified similar errors also in other texts in our corpus. This is a sample of the textual output for the same words. Tint outputs a JSON file, while UDPipe2 and Spacey output a tab-separated values file. And here, now we jump to the conclusions. The basic NLP tasks which are needed for more advanced studies on phraseological complexity are offered by all the toolkits analyzed in this work, albeit in different versions, while more advanced features are offered at different levels by the toolkits, but they were not considered and analyzed for this work. And our tests identified better performance by Tint and UDPipe for the basic Italian language NLP tasks. So thank you everybody for listening, and if you have any questions, I'm here.
Okay. I don't know if we are hiring. Yes, thank you very much, Giulio. Any question from the rest of the public? If no question, we go ahead to the next speaker because are kind of tight in the schedule. Please. Next speaker is, sorry, we wear the mask because of COVID and we are too close. Okay, now. So the next speaker is Valentina Franzoni, which has presented the paper together with the co-author Jana Kozak, which unfortunately is not here, is on yeasts automated classification with extremely randomized forests. Sorry. So please, Valentina, you can present whenever you are ready. Thanks. Okay, Valentina, welcome.
Okay, so let's speak about this presentation, yeast automated classification with extremely randomized forests. I am Valentina Franzoni from University of Perugia, Department of Mathematics and Computer Science. So basically, this presentation is in the area of e-transformation for health management. So in the same area of the keynote that we could follow 2 days ago by Professor Sumi Halal. So the yeast infection is a very relevant problem because there are a lot of pathogenic yeast species which are resistant to pharmaceutical agents, have evolved quickly over time, so can still evolve in different strains, and often cannot be stopped with antifungal treatments. So they are troublesome for weakened immune system patients, especially in outbreaks that are often found for Candida strain in hospitals and healthcare facilities. And the problem, in particular for the Candida strains, is that Candida can live for weeks on walls and surfaces, and also on prosthetics and replacement of internal organs, and so on. The Candida infection is by the Saccharomyces yeast of the genus Candida, which comprises over 150 species, which are different for classification. They can be found on the skin and the mucous membranes of animals, especially mammals, and they are the most common cause of fungal infection worldwide. So many of these species are not dangerous because they are harmless, but others, when the mucosal barrier are disrupted, for example, for a compromised immune system, they can invade and cause opportunistic infection, leading to death. So we need a rapid classification of the Candida yeast in order to properly apply the cure. So our research problem is that a new rapid and reliable method for classification is needed for spread prevention of Candida, and the actual performance of classifiers is not studied for Candida classification. And by our preliminary studied, we will see that they are not particularly remarkable as a performance. So our research goal is to explore the different classification techniques and to improve them with the feature extraction and selection for the Candida yeasts. The Candida yeast classification includes a lot of different Candida yeasts, and our current classification that we are using in this study includes 8 main strains of Candida. So Candida albicans, dubliniensis, glabrata, crusei, lusitaniae, orthopsilosis, parapsilosis, and tropicalis. And similar strains can give rise to a lot of different variations based on the geographical area, on the organic environment and conditions, and even from condition of the intracellular and extracellular medium or fluid in which they live. Our data set comes from University of Perugia. It's called the Semin Macrobial Collection, and is done by the Laboratory of Semin, which is a center of excellence for nanostructured innovative materials for chemical, physical, and biomedical applications. So in this lab, the genomic DNA is extracted using FTIR, which is Fourier transform infrared spectroscopy with a particular tool, machine. And this technique is based on the vibration of molecular forms in response to infrared light. The result will be a vector of pure numbers describing the absorbance of the molecule. And this collection includes 1,600 different strains. Before the classification, for the preliminary experiment, we balanced the classes because some classes were not balanced, and so we removed some random samples of the overrepresented classes. And so we obtained over 2,000 samples for each strain for 5 of the 8 strains. This preliminary experimental phase was done on 3 basic classifiers: logistic regression, support vector machines, and extremely randomized trees. So we can see that from this preliminary phase, the average precision is acceptable. but the performance is not distributed uniformly among all the Candida classes. So some of the classes can be correctly classified, but in particular two classes, the orthophiloses and parapsiloses, are misclassified in about 15% of cases. So what we would do is to improve the classification strategy with two approaches, feature selection and feature extraction. So basically, the difference is that feature selection reduces the number of features and removes the noise of the data, focusing on the most significant features, while for feature extraction, we produce new features, generating them as functions of existing ones. The feature selection has been done with randomized trees, and we estimate the relative relevance of feature for each strain, where you can imagine that the randomized trees has the form of a tree graph. So the features that have low depth will contribute to the decision of a larger fraction of samples or the leaves of the graph, and so can be considered more important. Averaging the predictive ability of each of these features over several randomized trees, we perform the feature selection. The other approach, the feature extraction, has been implemented with principal component analysis for a dimensional reduction, so grouping and combining the features to create new ones. We then created 25 relevant features out of the original 1,600, and we see from our preliminary experiments with respect to the preliminary experiment that with these 25 features, the model performed better than before, while with more feature or less feature, the performance was not better. So 25 has been identified as the optimal number of feature extracted. The results have been evaluated with the metrics of precision, recall, accuracy, and F1, where precision, accuracy, and F1 are the most relevant. And the systematic experiments have been done on these pairs of classifier and feature extraction or feature selection strategy, obtaining the cases in the list in the actual slide. So the recall, we can see that on the two strains of Candida that before had some problems is improved, and on the other ones did not decrease. About the precision, on average, we can see that in this case, in the preliminary experiments, we had two classes with 80% of precision, while now we are, for all the classes, above 90%. And CO was one of the Candida strains that had a low precision. Now it has a 19% precision, while all the others are very high compared with the previous 96% is the lowest, and 99 is the highest. About F1 as a measure, we see the same. So we have only one strain with a bit lower performance, but still close to 90% because it's 87%. And we still have all the other classes with a very high performance, close to 98, 99%. So as a final comparison of these average metrics per classifier, we can see which classifier can have a higher accuracy and higher precision. So in this case, the support vector machine with feature selection has the highest performance with all the metrics. In fact, the only metric on which this algorithm with this feature approach that doesn't have the maximum is the average precision. But the average precision has a 95.2%, when the 95.1% is the one of this subtle vector machine with feature selection approach. So very, very close to the top. In conclusion, we can see that the proposed feature selection or extraction techniques dramatically improves the original classifiers as we desired, and the overall best performant classifier is the extremely randomized forest, both as a classifier and as an algorithm for the feature selection. So the extremely randomized forest is a very relevant algorithm for Yeast strain classification.
Okay, thank you very much, Dr. Franzoni, for your talk, for your presentation. Is there any question, any participant who want to submit a question to Dr. Franzoni? Please, go ahead.
I could say something or to comment something on Valentina.
Eligius, please.
Yeah. I'm visible? Okay. Hi, guys.
Okay, now we are
So what Valentina showed was very interesting because she compared several classifiers over here on high-dimensional data. One thing I would always like to say over here is that the samples that I used to test these classifiers, you said something that they were random samples from the data you had. No? So because I think I was triggered because you started with logistic regression. So in logistic regression, people have been thinking a lot in the past about optimal design of experiments. And I translate that actually we shouldn't randomly select the samples for but we should select them according to a criteria. At least this would be interesting. So, but then because you compare several different classifiers, then actually for each classifier, perhaps this selection would be different, which would be very bad for comparison. So it's a kind of thing I would like you to think about at least. No?
Yes. So there is one part that I didn't say because let's say that we lack a bit of time, but in the preliminary phase where I spoke about these three main classifiers, we tried the classification both with and without the balancing to check if this data reduction doesn't have a bad effect on the classification. And then, of course, the advanced technique of feature selection and feature extraction is not random, but it's done
according to a criterion, which also makes some sense.
So this is the focus, but thank you for your question, because it's important to tell that we checked that in the preliminary phase of balancing was not...
Okay. Thank you very much.
Thank you. Altre domande online, se no vado. Altre domande, se no vado.
Okay, is there any other question? So, any other question? No? Thanks. Thank you, Valentina, very much. Thank you, Eligius, for your questions. And I think we can go ahead to the last speaker of this section, which is Guido Biondi. I'm asking, there is a participant which is sharing a screen, and I would like to ask you to check that if you are not sharing the screen, because we would like because it's going to interact with Jitsi. Okay. So please, register. I ask you to check this and ask to Dr. Giulio Biondi, recently PhD, graduated, to present this paper, which is a moment, okay, which is a joint work with myself and from the University of Perugia as well. So please, special assignment, optimization vaccine units in the COVID-19 pandemics. So please, Giulio, you can present. You can start your presentation.
Thank you, Professor Milani. Today, I'm going to talk about special assignment optimization of vaccine units in the COVID-19 pandemics, problem which unfortunately we all had to face in the recent times. So the goal in such problems is to optimize the cost of building and running vaccination units, which is a difficult task, especially during a pandemic, because the logistic efforts have to be concentrated into a really short time in order to start as soon as possible the vaccination campaigns. And every country had to struggle with such problem recently. And so models are required in order to optimize the distribution of such facilities to contain the costs and at the same time deploy them as fast as possible on the territory. In defining the distribution of healthcare facilities, not only vaccination centers, but in general, the following factors are considered in literature. Availability and accessibility are two factors which are solely related to the territorial distribution of facilities. Availability counts how many facilities are available for a population, and accessibility, or how can they be accessed and reached by the population. And while the other three factors, affordability, acceptability, and accommodation, are related to the social and economical aspect of a country. So it can vary from one place to another depending on the healthcare system in that country. To solve the problem of optimization, various classes of measures have been proposed in literature. The following three classes are the most studied in literature and are provided to population ratios, travel impedance models, and gravity models. For our work instead, we propose a model based on a layer structure. So the layer structure models the territory characteristics by defining a grid and defining several layers describing different aspects of the environment. The resolution of the grid determines how much in detail we model the considered territory. And our model is easily extensible because additional layers can be added to the model to describe different characteristics, for example, social aspects. Now we will have a look at the main layers constituting our model. The first one, of course, is the population distribution layer, which models the distribution of the population through a grid where each sector has an amount of population. And in this particular example, you can see that the population is well scattered through the territory, and there are some empty cells where there is no population, which can correspond, for example, to rural areas or infrastructures. and some other which are more densely populated. In our model, we can take into account different population types, for example, based on economical factors, and the granularity of the analysis defines the computational complexity of the model. So going more into detail, we can have a finer representation of the population distribution, but of course this will require more computational resources to optimize a solution. Another important layer is the transportation infrastructure layer. In our model, we use this layer to identify how the population can move to the nearest vaccination center. In any tile, there is a number which describes the distance from the center to the edge of the tile. Several transportation layers can be defined for different transportation means. For example, the first one in the top right corner describes roads. So one can move from the tile on the bottom left to the tile in the middle by car, and one can calculate the shortest path for such a movement. While the tile on the bottom describes, for example, tube system, where some tiles cannot be reached because, of course, the tube follows predefined routes. So the shortest path from one place to the other can have a different length. And we also consider the possibility of interconnecting different layers, for example, when a location can be reached only by with a mix of means. For example, taking a bus and then taking a tube, which is fairly common in big cities, for example. Another important layer is the COVID facilities layer, which actually is the output of our model and describes where the vaccination units will be placed in the territory. What you see here is the symbol of the vaccination campaign in Italy. And in this example, we have one vaccination unit in the top left area and two vaccination units in the same area. This is because in our model, we also take into account the advantage of building bigger vaccination units, which have reduced costs because the facilities and the infrastructures have to be built only once, and they will serve the multiple units. So of course, the cost will be different and lower than building different units in different places. So for our problem, we have the following inputs: the number of vaccination units we are willing to build, and the cost of building the units, and the running cost in the considered time horizon. Then we have, of course, the population distribution of a certain territory, the transportation maps describing the different means of transportation in the area, the time horizon, so how long will the campaign last, which is connected to the running costs, of course, and we can have additional parameters, for example, population transportation mapping, where we consider different populations using different means of traveling, and waiting time penalties in case the units are not sufficient to serve all the population in the nearby, and therefore queues can form or accesses have to be split along a longer time period. And this is, of course, our overhead, which must be taken into account in the problem. And optionally, also other factors, like economical factors or social factors, can be included by adding additional layers to the model. Additional layers which constitute part of the fitness function, which is a sum of the following parts. So the building and running costs we mentioned before, the hospital overhead, so when there is no sufficient, there are no sufficient facilities for all the population which is served by that hospital, and taking into account also the distance of each population sector from the nearest hospital, and the already mentioned additional layers. So these contributions will be summed to calculate the fitness function which will drive the optimization process. We consider for the experiments the following algorithms: covariance matrix adaptation, particle swarm optimization, two varieties of differential evolution, and SCR Hammersley search. And we also consider the random function as the baseline. We gave different budgets to see if the process would improve with an additional higher number of fitness evaluations. And we created 10 sample data set with grids 10 by 10 and 600 people living in the area, and road segments of 1 or 2 kilometers for each tile. All the experiments were performed using the Nevergrad environment. So these are the results. These are the mean scores achieved by the algorithms with different budgets. We can see that differential evolution, either in its basic form or using the 2 points crossover, achieved the best results for all the considered budgets. And other algorithms like covariance matrix adaptation achieved still good scores, while particle swarm optimization on average is left behind. Also, the Hammersley search achieves good results. In any case, we can see that all the optimizers achieve scores which are apparently better than the random search, which randomly places units on the territory. So we can see that all the optimizers actually can find better solutions over time. And performance does not improve that much after a given budget. So after 3,500 iterations, we can see that there is no noticeable improvement, or in some cases there is a degradation of performance. So these are the best scores achieved by the optimizers, and as we can see, they confirm the findings on the previous table, because differential evolution achieves the best results in both its flavors, and achieves also the local minimum of 16K approximately, while the other optimizers are nowhere near that, with covariance matrix adaptation achieving almost 17K. So to jump to the conclusions, we described a flexible layer-based model for the optimization of distribution of vaccination units on the territory. We test several optimizers to find the best distribution. And from our tests, we can say that the best performer for this kind of task with our model is the differential evolution algorithm in its basic form, or using the 2 points crossover. Future works will aim at experimenting different resolution grids with the computational resources trade-off we described before, and also differentiating the building cost with respect to the characteristics of the territory, because, for example, public infrastructures have almost constant costs because of the power of the state, while private infrastructures can have very varying costs to build, to acquire the terrain and building all the needed infrastructures. So this can also be taken into account while defining the total cost of the model.
Okay, thank you Thank you very much to Dr. Biondi for his presentation. We are running close to the next session, which is planned for 11:30. So we have just time for a quick question. Please, Eligius, because I'm a co-author, I'm not supposed to ask a question.
You're a co-author.
So we have
you shouldn't say anything.
again.
Am I somewhere?
Yeah, hello.
So
No, you
Eligius.
should.
Okay.
Oh,
So this is really even more my
hello.
field now. So one of the suggestions for further research,
Hello.
or what we are very
Sorry, is there a participant which is speaking is not supposed to speak, please? Turn off your mic.
So one of the main suggestions I have.
Yeah, I still have my paper to present.
Sorry, please. I don't know who is talking. You don't have a name, please.
Kennedy.
Okay, we talk to you next after this question. Please, I have a Professor Eligius, so you can go.
Okay, so this story that Giulio was just sketching, which is an assignment problem, my suggestion is first, or I would have liked also, if you did in the past, first to try a branch and bound type of algorithm to see whether we can solve this to optimality. Because the things you suggested were all methodologies based on random search technology. But it could be that this problem can be solved up to optimality so that for each instance we know exactly what's the optimal solution. So it's a matter of writing this as an MLP, for instance, in GAMS or any language, and there's a free solver online where we can try to solve it.
Yeah, so this is very interesting.
So this is what we're going to do next week, isn't it?
Exactly.
Next week we are going to solve this.
So, yeah, first
or not,
step.
because it's not guaranteed that branch and bound solvers are able to solve it when the problem is too complex. But with my intuition, I feel that we can solve it.
Yeah, for sure. It's really, thank you for the suggestion. It will be really interesting to try them. For now, we focused on the differential evolution and other genetic algorithms because they had the requirements we were looking for. So a fast optimization type and fast prototyping. So that's why we analyzed them in the first place. But surely with this model, we can extend the solution to other techniques.
Okay,
so for sure this will be done in the future.
Yes, so you will see the solutions next year. No? Okay.
Of course, in the same workshop.
In Malaga.
Okay.
Thank you.
So I thank you and everybody for participating for attending this workshop. I remember you is the 10th edition of this workshop. So it's a very long tradition. And the tradition is supposed to continue next year in Malaga, in ICCSA in Malaga. So I ask you to submit. And again, I made an announcement that the best paper of this workshop will be invited to a special issue of a journal. So thank you very much and see you in the next future around, hopefully in person. Okay, bye-bye.
Bye, thank you everybody.
I leave a place for the next workshop.
Bye.
Bye.
Because the next one...
We are the next workshop, actually. Let's wait a minute. Can you hear me?
Yes, we can.
Okay. So, hello to everyone. My name is Ioannis Politis. I'm assistant professor at the Aristotle University of Thessaloniki in Greece. I would like to welcome all of you in this session, which we have 4 presentations. And since the duration is 1 hour, I propose to the speakers to have a presentation of about approximately 12 minutes and to leave some space for Q&A for 3 minutes. So I invited to the floor Mr. Kennedy Okafor for the first presentation. Kennedy, you have the floor.
Thank you very much, Chair. Thank you very much. I will try and be very brief. I'm having some little health challenge, but I made effort to try to come in and then make my presentation. Thank you. Okay. So, okay, if you can see my screen, please let me know.
Yes. Can you put it on full mode? Full presentation?
Okay. I'm trying to do that now.
You can press F5.
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 F5 is not responding. Okay. I don't know if it's better now.
No.
You can click slideshow and then in your tab and go to, then you say start from beginning.
Oh.
It's like it's a version different.
Yeah, I think it's version problem with.
Excuse me, Mr. Politis, I'm Rafaela, your room assistant for this session. Maybe the problem is that you have to share the screen after you go in a full screen with your presentation. Because if you go full screen before you share the screen, when you share the screen, it's closed. So please go to the screen and share your screen on Jitsi.
Yeah, let me I'm having issue expanding this.
It's okay. You can do the presentation as it is, and you can click on the slides. Okay.
Okay. Thank you. Let me manage. I think it's a version problem. So I want to start by thanking the chair of this section. My name is Kennedy. My co-author is Umumuri Mary Lunch. The title of our paper is Computational Wrist Print Biometric Identification System using Discrete Cosine Transform. So this is our presentation outline. We look at the biometric wrist authentication outlook, contextual concerns, why discrete cosine transform for image compression. Look at the system formulations, system architecture. We look at the DC enrollment solution space features, DCT identification space solution space, model integration, experimental study, optimization, conclusion, and we close out the work. So biometric wrist authentication is one of the best known authentication scheme in many access control systems. And the use of print biometrics as humans attempt to communicate with machines and robots and their environment have inherent setbacks, especially the minute complexity. Various efforts have been proposed to fix the limitations. And most biometric efforts suffer from lack of computational derivatives, and they do not support optimal image compression. So motivated by this concern, the goal is to leverage discrete cosine transform to compress palm print images and develop a wrist print biometric identification system. We are looking at building systems that could be used in the banking sector, ATM machines, access control door systems, and all that. And so DCT comes handy. So development of a process model for DCT and characterize it for wrist templates, considering both original and decoded images is very important in this research space. And the compression ratio and the bits per pixel for RISC templates, or what we call bioscripts, are used as metrics for evaluation. And so we need to look at how this metric can help to optimize the risks for access control. So there are so many personal identification systems, authentication systems that provide accurate and reliable recognition system. In cases of terrorism and other forms of illegal activities such as e-commerce fraud, many of these access control systems have become very handy. And in mission critical access systems, biometric initiatives that will improve security ideology are always sought. So people are looking for access control systems that have robust security so as to protect such systems from vulnerable attacks. So biometric, to date, biometric is very useful in areas of forensic, commercial applications such as banking sector, voting systems, and other recognition systems, especially in Africa, where we have a whole lot of security vulnerabilities in access control systems. And so biometric encryption, biometric cryptography, fuzzy vaults are some of the trending technologies, but to date, no work in literature has dealt with biometric risks, authentication-based discrete cosine transform for image compression. So, existing work have not fully explored the potential of image compression using DCT, especially in the context of a wrist-print biometric identification system. And so DCT is a signal to elementary frequency component conversion technique that's commonly used in image compression. So if you look at access control systems that have lightweighted computation, we saw that DCT is an optimal scheme for such system. The major benefits of DCT include well-defined data points summation at various frequencies, which is ideal for image compression. High efficiency for image compression, since fewer functions are required to estimate risk signal. Approximately twice as long as discrete Fourier transform logic operation on real data sets with even symmetry only. So DCT is lightweighted and is very adaptable. Adaptable to access control system. So in trying to formulate our system, we try to build a system enrollment and verification algorithm. And this enrollment algorithm is broken into three stages: processing of image, key linking, identification code creation, and then the verification algorithm has three stages: image processing, key retrieval, and key validation. The enrollment procedure goal is to build a user RISC bioscript by linking arbitrary and bit key to user RISC print. So if you look at the diagram by my right, you will see the RISC PAM biometric encryption enrollment process having the image processing, the lookup link algorithm, and then with the bioscript, and we have the hashtag used in ensuring that the access control is very strong against vulnerability attacks. So enrollment is very important in the first phase. So we have the enrollment solution space features. This algorithm controls the enrollment process with the bioscript. The first algorithm, we use this algorithm to track the enrollment procedure while enrolling user biometric print into a remote database that could be authenticated for access control. So we have the identification process again for biometric encryption. So for image processing, stage 1, we have the lookup table, we have the retrieval algorithm, we have the encrypt bioscript for identification. So with this, it's possible to actually identify a legitimate user within the biometric application. So retrieval and the validation of the bioscript is very important. With the bioscript, we can actually ensure that the entity enrolled within the biometric system is actually a legal entity. Otherwise, it will be subject to vulnerability attack. So we have to consider the retrieval and the verification space from the bioscript perspective. Once the image is combined and stored with the lookup table, it's easier to use the bioscript to identify the entity within the RIST biometric identification system. So the system here for the image compression has redundancy elimination, irrelevancy reduction, layered pattern recognition for the RIST print biometric identification system. So with this diagram here, we have our DSP, digital signal processing core that processes this image print with the bioscript, and to be able to actuate control at the output and then create access control for the end user. So our model integration has enrollment verification. The first, we'll have the linking algorithm, enrollment and the authentication, and then the retrieval key for the bioscript. So with this integration, we are sure to have a very robust security system. So this is the biometric sensor connect to the hyperterminal for the hardware device when deployed. And then we try to use MATLAB image vision to create the validation for the process model, the image compression. So in our model, we were able to capture various bioscripts and then test them out for stronger authentication. And then we were able to generate metrics like throughput for biometric image samples, generate risk, image intensity for wavelets transform. And when we compared that, we were able to see a RIST image display estimated at 93.55, which is significant for DCT throughput compression ratio. With the application of various timestamp, the image compression of 63.26 based on DCT was observed. So the wavelet scheme offered us 33.30 RIST image intensity, and our proposed offered 66.70 image scripts. And that shows some level of optimization, which is very, very useful for the image compression. There's a trade-off within the computational system resources. A whole lot of resources are required to process this image bioscript for multispectral images efficiently, and that is a very big challenge when deployed in a light weighted hardware. That could actually draw a lot of system resources, and that could be a big problem. So part of the work we're looking at again is to see how to make it lightweighted so that computational system resources will be minimal for the DCT. So in our conclusion, we've been able to build a proof of concept of this particular system, the biometric RIST authentication, based on the discrete cosine transform for palm print image compression, and it's presented as an optimal scheme for image compression. Image compression is very important for security systems, especially when you're going to be using palm print, binary image. The 3D and the 2D focal points are very, very sensitive. So again, resource optimization is a very big consideration, and that's actually the trade-off here, because the system resources required to process this palm printed binary image in this work is still very high. So we need to work on it and then reduce the computational requirements so that it could be a lightweighted image compression system. So in summary, the BWA leveraging DTC is useful in biometric access control systems, and this has been applied in the digital signal processing block for palm print image compression. I want to thank you for listening to us, and future work will look at this optimization, and we'll compare it with other machine learning schemes so as to be able to maximize the image compression. Thank you.
Thank you very much, Kennedy, for this presentation. Although I am not an expert on the field, I understand very well that in this world that we are living, the safety and the security issues and the access control issues are very important.
Yes.
These are very important. I don't know if we have any question from the audience here. No. Okay, I would like to thank you very much for the presentation. And
thank you so much.
Let's move on to the second presentation, which is from my colleague, from Ioannis Fyrogenis. Can you reshare the screen, Kennedy, so as to move on to the second presenter? Okay, thank you.
Thank you very much.
Thank you too. Yanni, you have the floor.
Hello. Can you hear me? Can you?
Yes.
Let's see if I can share my screen so that it is in full mode. Can you see it?
Yes, it's in full mode, so you can start the presentation.
Great. So, virtual greetings from me as well. My name is Yannis Fyrogenis. I'm from the Transport Engineering Laboratory of the Aristotle University of Thessaloniki. I'm presenting this paper on behalf of quite a large group of authors, as you can see, and it's called The Holistic Approach to Optimize and Promote Bike-Sharing Systems Through an Integrated Action Plan. More specifically, this work is part of a project called Change, or Enhancing the Bicycle Share Economy Through Innovative Services and Applications. And the aim of Change is to promote bike-sharing systems and shared mobility overall by combining traditional parts of the mobility ecosystem, such as infrastructure, vehicles, users, with additional information such as weather conditions, potential users, social media posts, information regarding alternative modes, and actions and interventions that can promote or enhance the system. Towards that, during the start of the project, a system architecture was conceptualized and brought to life that collected data from a fleet of electric dockless bikes, combined them with additional data, and attempted to extract useful information from them. More specifically, the result of that work was the platform called iChange that monitors a fleet of 200 electric dockless bikes in Thessaloniki, Greece. The data collection is fully anonymized and compliant with GDPR, and it gives the operator a very concise look of the current status of operations. For example, bicycle locations, their battery status, the trail of the trips on the map, the starting and ending points, as well as the status of the vehicles currently available. Now, this platform was used in order to monitor and quantify the effect of some promoting and enhancing user-based and system-based actions. Those are, the first action promotes commuting. It provides incentives to use the system for trips to and from work. The second promotes the use of the system from city visitors for tourism. The third integrates a gamification and rebooting system in the bicycle share system that gives virtual rewards and badges to the users for performing certain tasks, as well as allows them to have a bicycle available when they reach certain points. And last but not least, a bicycle for users with disabilities was designed and constructed. Starting with the commuting action, the first thing we had to do was to pinpoint the factors that affect the willingness to commute via a bicycle share system. First of all, a person's lifestyle is crucial. Also, their actual and perceived safety and comfort while using the system can affect their choices to use it. The cost, time, and effort it takes to use the system, especially compared with alternatives, is very important, as well as their ability to ride a bicycle both physically and mentally. The health benefits that come with using the system are also a huge benefit for them, as well as the available infrastructure, especially bicycle lanes. Of course, there needs to be efficient and adequate bicycle availability. Some incentives were offered to users in order to participants in this action in order to encourage them to use the system. And first of all, an introductory incentive to all participating users, but gave them 20 euros in order to get to know the system. Apart from that, a commuting incentive that offered 10 euros per week for 3 months to every participant that performed at least 3 commuting trips to and from work during that week. Also a commuter of the month incentive that offered 100 euros to the participant that made the largest distance using the BSS system during those 3 months for each month, regardless of whether those trips were made for commuting or not. In order to bring this action to life, we partnered with 2 of Thessaloniki's municipalities, the municipality of Thessaloniki and the municipality of Kalamaria. And they were chosen as they have a large distribution of working locations and a large number of employees, but were close or inside the working area of the bicycle share system. First of all, potential employees, potential participants were asked to fill an online survey in order to gather some information about their habits. And then the bicycle share area of operations was adjusted in order to accommodate their needs. Afterwards, the participants that were eligible were offered the introductory incentive, the 20 euros, and their trips, their everyday use of the bicycle share system were monitored, of course, with compliance with the GDPR. Lastly, they were asked for feedback to give us their experiences while using the system in order to be able to improve it in the future. Moving on to bikes for tourism. Again, we first pinpointed the factors that are crucial for a bicycle share system's touristic success, which were found to be the accessibility to the system, the synergies made with other stakeholders regarding tourism in the city, the available infrastructure, especially bicycle lanes, advertisement of the existence of the system and how it operates, adequate information regarding how someone can rent a bike and use the system, the available points of interest that can be easily visited with bicycles, as well as an integration of cycling culture in the local society. For this action, we partnered with 4 hotels, 3 of which were in the city center downtown, and a 4th, which was close to the city center, but at a distance which was considered easily cyclable. The hotel staff was trained and promotional material was installed on the hotel locations. And more specifically, on the left, you can see the poster that informed the visitors about the system. And on the right, both sides of the leaflet that was distributed to interested parties that has the, detailed instructions on how to rent a bike with the system, as well as exact locations of points of interest that can be easily visited using the system's bikes. Moving on to gamification and rebooting. This is the Easy Move app, the app that the users can use to locate and rent bicycles using the system. And pre-booking reservation module was added on the app that allowed users to rent a bicycle up to half an hour before reaching it, so that they would feel safe that there would be a vehicle waiting for them when they reached it. Also, a gamification module that enhances and promotes user interaction with the system was added, and it offers a large amount of incentives to keep using the system. More specifically, some missions ask users to explore certain landmarks using the system, and those landmarks, as well as the distance from them the user needs to pass from, are fully customizable by the system operator. Another type of mission are parking missions that ask users to park their bikes near well-known locations of the city. Again, it is fully customizable and it can be used to tweak the system in order to accommodate rebalancing needs, in order to have bicycles available where the system needs them. Furthermore, a mission that accommodated the needs of commuting was added, that asked the users to do back and forth rides with a minimum amount of time between them, which accounted for commuting rides using the system. By fulfilling all those missions, the users were able to level up, gather points and badges that translated to both virtual and actual rewards such as free rides or monetary incentives. Last but not least, as we said, a bicycle for users with disabilities was conceptualized, constructed, and I cannot stress this enough. This is more than just another transport mode. We saw it as a window of opportunity for a whole social group to participate and be part of social activities and days in the city, which would otherwise be closed off to them. We examined a large amount of templates of vehicles, of pedaled vehicles that accommodate the needs of users with disabilities, both two-seat vehicles, hand cycles, pedal cycles, three-wheeled and four-wheeled vehicles. And in the end, we decided to go with the wheelchair-carrying tricycle. A large conundrum we had to solve was whether to use the tricycle or a hand cycle. But the tricycle was chosen because it gives the user the opportunity to have his wheelchair, his necessary equipment with him, and carry on with his trip after using the bicycle, while the hand cycle doesn't allow him to carry necessary for him equipment with the vehicle. So as far as trips come, we went with the vehicle that allows to carry any type of wheelchair. During the vehicle's design, you can see the vehicles that were constructed on the right. We faced many challenges, and we solved them with feedback from the Panhellenic Association of Paraplegics. More specifically, the dimensioning of the vehicles was crucial since they needed to fit available infrastructure. The safety, both actual and perceived, was a very dominant matter, as the users need to both be and feel safe while riding the bicycle. Boarding mechanisms were also a problem, as there needed to be a way for both lighter and more heavy wheelchairs to board the vehicle safely and without needing too much assistance. For example, an earlier version of the vehicle needed two people in order to board a wheelchair, so that was a problem. And also, we needed the vehicle to be able to move and be agile while carrying heavy loads of weight. So the vehicles have an electric motor, they are pedal assisted, and they offer adequate maneuverability in order to go through the city's bicycle lanes. In conclusion, a holistic approach such as that can concurrently tackle DSS promotion and optimization throughout the system. It can take advantage of new features in order to promote certain aspects of the system, of the bicycle share system, and it can also offer better service to the current user base while expanding it and making the service available to new users and social groups such as users with disabilities. Of course, the feedback from those results and the quantification that was made using the iChange platform can be used to further advance future approaches. Thank you very much for your attention. If you have any questions, I'm at your availability.
Thank you very much, Ioannis, for the presentation. We are on time if there is any question. Okay, just to say here that the two prototypes bicycles that were developed within the project are the first of that type, and they have attracted the interest of both industry and political side. Okay, now let's move on to the third presentation. I don't know who is gonna make the presentation. We cannot hear you. Sorry. Can you tell us your name and you can start the presentation?
Yeah, thank you very much. I'm sharing my screen. So
yeah.
I guess you got my screen, right?
Yes, we are seeing your screen,
Okay.
but not your presentation.
Oh. Okay, let me try. Yeah, it's actually working. I don't know, somehow it is hanged.
Now we don't see your screen. We're just seeing yourself.
Yeah, because it's the mouse is actually circling around. I think it's a working background. It's telling me it's not responding. So yeah, I guess we have to wait a little bit. I'm sorry.
It's not a problem. Let's see if the last presenter is here. Maybe we can move on to the last presenter until you find a solution.
Right.
Yeah, I think it's better. Okay, let's move on to the last presenter, and then we will return back to you.
Okay, thanks.
Is
Mutasem.
Mutasem, okay.
Yeah, I'm available. Yeah. Okay, so let me share my screen first. One second.
You are muted, Mutasem.
Yeah, okay. Can you hear me right now?
Yes, of course.
Thank you so much. Really appreciate it. Just allow me to share the screen. One second, please. Yeah. Can you see my screen right now?
Yes, if you can press the full mode.
Yeah, I pressed it. Yeah. Is it now in the full mode?
No, you can press escape and we will see the presentation from, yes.
Okay, okay, I'll try to fix that, no worries. Yeah.
Yes. No, it's not a problem, we can see it as it is.
Yeah, okay, no worries, I'll try it again. Just one more. Try. Yep. Now it should be in the full mode, right?
Yes, it is, yeah.
Okay, yeah. Okay, first of all, thank you so much for giving me the opportunity to participate in this conference. This research was done by me, Mutasem Darwish from Jordan, Middle East University, and two colleagues, Tiziana from University of El Nacor in Italy, and Dr. Ghaida Abroman from Isra University in Jordan. In fact, our study or our research studied the impact of COVID-19 pandemic on the perception of public transportation users in Amman, the capital of Jordan. As you know, the global pandemic, the COVID-19 global pandemic hit many sectors, in fact, commercial sectors, health sectors, and transportation sector. Transportation sector was among the most affected sectors, in fact, by the COVID-19 pandemic. Therefore, we agreed that we need to study the impact of this pandemic on the transportation sector, but from the user perception. How do they feel or what do they expect during this unusual situation or during this pandemic? What you see here right now is a graph showing the usage of public transportation in 4 different cities around the world: Dubai, Amman, which is the place of the study, Manchester, and Rome. And as you can see, starting from February or late February to early March, a major drop, almost up to 100% occurred in the usage of public transportation, and it stayed for almost throughout the duration of the study, which was from March to October. The drop was obvious, and it was varying between 40 to 80% of the drop, which means that public transportation sector was hit aggressively, in fact, but by what happened from the pandemic. So first, before talking about the impact, let me introduce the public transportation sector in Jordan, because it has some characteristics that you should be aware. In fact, the public transportation sector in Jordan was evolved and developed in an unorganized way, in somehow, or away from the governmental regulations. So it developed in a heterogeneous manner, and that was which added many problems to the sector. In fact, the sector suffers from the lack of subsidies from the government, for example, lack of professional transportation companies, bad taxation regulations, which support individual ownership instead of public or governmental or public or even companies over ownership. In addition, for example, buses mostly they do not have a timetable. They will leave only when they are full. So the sector already faces many challenges besides the governmental bureaucracy. In fact, a very important report was issued in 2017 and reached to the result that the whole transportation sector in Jordan, public transportation sector, needs a reformation. However, when the corona came, it hit the public transportation, and it added the COVID came. It added insult to injury. In fact, the first COVID case in Jordan was reported 2nd of March, and the government acted promptly because the public sector is kind of susceptible, and can't hold any aggressive pandemics. And therefore, they announced by the mid of March, they announced a complete lockdown, closure of borders, banning of private cars use, banning of traveling between cities, intergovernmental travel. It was banned up to the end of April, where they started to ease the lockdown starting from May. Yet the government imposed many restrictions on traveling and enforced many measures to reduce the spread of the pandemic. So, for example, it allowed open for a few sectors, hospitals, hospitals or malls or shopping places for groceries, and avoided the opening of public gathering places like, for example, the schools, cinemas, malls, and all these things. In addition, they prevented the usage of private cars, and they supported the use of public transportation to reduce the mobility of people. However, they enforced the public transportation. They enforced many measures in the public transportation, such as, for example, mandatory mask policy, social distancing, disinfecting vehicles on a daily basis and twice on daily, even adding barriers between the passengers and the driver. So they tried their best to reduce the spread of the pandemic through the public transportation. However, when we started our research, we suggested to use to circulate a standardized survey for participants, and the most important condition was those who will participate should be in Amman, the capital of Jordan, from March to October 2020, and they should have used the public transportation. We circulated the survey using Google Forms, and the participant was introduced for our study and the purpose of the study. Generally speaking, the survey collected 3 types of data, in fact. Socio-demographic data, like the age, the gender, level of education, the public transportation user behavior, like frequency of using public transportation, frequency of walking on foot to and from walking places. And finally, it was the perception of public transportation users. Do they feel anxious? Do they feel safe? What's their perception of the public transportation infrastructure in Jordan? This is part from the questionnaire or the survey that we distributed or circulated, which people answered anonymously, by the way. And by the end of this, the research, more than 500 people, in fact, participated in our research, which is a representative sample, bearing in mind that in Amman, the population of Amman, around 4.5 million people. The results showed clearly that the public transportation sector was hit aggressively. In fact, during the pandemic, only 11% of people preferred using public transportation, even though it was the only allowed transportation method. While before the pandemic, it was 20%, so which shows a reduction of almost 50%. In addition, those who are using public transportation on a daily basis were only 4% of the participants, compared to 16% before the pandemic. Furthermore, we can see that when people were asked about the most important criterion for choosing the traveling mode, is it buses or is it cars, or they mentioned social distancing as the most important criterion. In fact, more than 50% of the participants reported that social distancing is the most important criteria, which shows which can justify the reduction in using public transportation, bearing in mind it's hard to achieve public transportation, to social distancing, in public transportation. Even though trip duration and trip cost, which were the most important criteria before the pandemic, were not the most important anymore, and only 22% of people indicated that they are important during the COVID. Finally, we can see an increase we can see an increase of using private cars from 32% up to 52% during the pandemic, which is justified again because people are kind of hesitant to use public transportation for many reasons we will come later in this presentation, and prefer using a more private traveling mode. In fact, moreover, the results showed that 60% of the public transportation users feel anxious while they are using the public transportation. Moreover, 50% of public transportation users and 40% of those who used to walk or walk on foot for to and from their working place or leisure places reported that the infrastructure is not up to standards and is not suitable to be used, which also shows that the problem of the public transportation is not related only to the organization of the public transportation sector in terms of timetables or the availability. Also, the infrastructure needs improvement. However, 60% and 80% reported that they will start using public transportation or that they will use public transportation and walking as travel mode if the infrastructure was improved respectively. Finally, from the perception of the users, 60% reported that public transportation lagged health condition, even though the government imposed, in fact, many regulations or many strict regulations to assure that public transportation is adequate during the pandemic. Finally, the results showed that there is. Excuse me, can you hear me?
Yes, of course. Yes.
Finally, the results showed that there is a significant relation between public transportation usage and the anxiety during the pandemic. In addition, level of education showed a significant correlation with public transportation usage only before the pandemic. However, during the pandemic, it shows no correlation, which is justified in somehow, because during the pandemic, it doesn't matter the level of education or awareness of importance of public transportation, or even the social status. Yeah, everyone is kind of afraid from using, or kind of cautious of using public transportation. Therefore, from the results in our study, it's obvious that people it is evident that people's use of public transportation was reduced, in fact, and the public transportation sector was hit aggressively, in fact. Moreover, the results indicated the importance of improving the walking infrastructure, because people were willing to use walking infrastructure. And in fact, supporting people to use walking infrastructure would help to reduce the spread of the pandemic, of the virus. Sorry, yeah. Therefore, this could be one of the solutions, yeah, to improve the walking infrastructure right now, to reduce the amount of people in each, or to reduce the stresses on public transportation. Finally, in our research, we recognized that people in Jordan were not sure that public transportation was safe, and that's obvious by the reported anxiety in public transportation. Therefore, the most important thing to regain the people's confidence in public transportation is to create a healthy atmosphere inside public transportation, and to assure that the enforced or the imposed measures, like wearing the mandatory mask wearing, social distancing, for example, the disinfecting of public transportation should be maintained to regain the public transportation users' confidence. In addition, people confirm that the current situation or the current measures are not enough, and they are expecting much more. Moreover, the results show the importance of improving the walking infrastructure in the country, because this could help to reduce the stresses on the public transportation. In fact, right now, we're trying to extend these results right now from October 2020 to August 2021 to compare the results between what happened during the first wave of the pandemic, when people were not aware of what does it mean, the COVID, and how to deal. And right now, while people kind of more aware, most of the people in Jordan, in fact, are vaccinated. So this research should be expanded. In addition, there is another comparative study, in fact, also in progress right now, where we're comparing the result of our research with results in similar cities where similar research was conducted. Thank you for your listening.
Thank you very much, Motasem, for this very interesting presentation. Actually, it's very impressive how the results of similar studies are similar worldwide, where we see people moving from public transport to their private cars due to the COVID-19 pandemic. For example, in Greece, we saw something very impressive. We saw advertisement in television from the Ministry of Transport, which support travelers to use their private cars instead of public transport. So the environment was rapidly changed through the COVID-19 pandemic, and we see all these very interesting outcomes that you provide us. Thank you very much for your presentation. It's very important to see how COVID-19 has affected our behavior and our choices. In
fact, even in Jordan, as I remember, the government tried to reduce the usage of private cars, by limiting the mobility of them. Yet people were going toward private cars because of social distancing. At least they feel less anxious.
Yeah. It's a completely different environment of what we had in the past.
Yeah.
Okay, thank you very much. Can we move on to the last presenter now?
Yeah, I am here.
Okay. We see the screen now.
Yeah, this time I'm not sharing video because I think last time I crashed it.
Okay.
So you got my screen, right?
Yes, we can see. Ernesto.
Okay. So no, I'm not Ernesto.
You are Abdul.
On behalf of my colleagues here, I'm Abdul Choudhury. I just finished my doctorate in the University of Politecnica delle Marche here. So I'm going to present this approach utilizing Landsat 8 OLI images to monitor mangrove forest dynamics. It was in southern coast of Sancti Spiritus province in Cuba. So the general objective was to characterize environmental, economic, and social subsystems in that in the particular place as called Jaza Basin. I'm going to get details later. And then to assess the relationship between phonology and reflectance with the Landsat images and the technique that we actually used, that multiple and spectral mixture analysis. And obviously, to set up an effective monitoring standard to this kind of region like mangrove forest, this approach is we found like really effective. So going on this Jaza Basin, it was actually a river, and those are the areas, particular features that we should have in our mind when I'm going on with the presentation. So it's better to have a look here, like low forest covers, degradation of coastal zones, steep slopes, density of fluvial subbasin, and so on. And the study area was in the southern coast. Obviously, it's called Sancti Spiritus. It's a province in Cuba, and here you can see also the coordinate and the very nice picture of the survey area. It was actually the study area. And the data set, obviously, Landsat all 8 OLI images, and those were collected from Geological Service from the United States of America. And here you can find some bands, obviously some details on the bands, just to have an idea that what we have used and how it will be going to the outcomes. And those are the data sets that during the field survey of 61 plots of 100 meters square, we considered to take these variables for this research actually. So you can see especially here like species of the dominant flora and the full coverage of like the fruiting, flowering, coverage of adults, coverage of yields, and so on. Also, there are some data set that we had to use from some geodata from different Cuban institutions, like geological maps, for example, soil maps, some demographic features, some planning land use features, landscape features, biodiversity, and so on. And this is the methodology that I was talking about, this multiple and member spectral mixture analysis. It really allows to transform original satellite images into new images with full physical meaning. So here you can see those steps that we applied and get these outcomes. Here, based on this methodology, you can see that actually we use is a Biometric Tool and so well-known Nlp software to move this coastal zone and to actually identify the mangrove forest by species and to understand their spectral reflectance species by species. So this is the interesting part where it comes like we had this kind of images, monotemporal and multi-temporal images, and we actually compared these outcomes. For example, here you can see that in order to determine the evolution of coverages, monotemporal images were more interesting. and multi-temporal images are more effective for analyzing impacts on fragile ecosystems like deltas, lagoons, mangrove forests, and marshes. And also there are some possibilities, like, for example, because of high complexity of deltaic zones of that study area, fractality and mixing among species in a 30 meter pixel of Landsat images. It was quite hard, I won't say not possible, I'll say it's quite hard to obtain good separability between the 8 classes. And you can see those 8 classes like red mangrove, black mangrove, white mangrove, other vegetation soils, water, lagoon water, and PEV. And also where here comes the results. So the most important thing is that here when with this approach, like MESMA approach, the fraction classes with good accuracy was until a set values of threshold like around 50%. We only we use multi-temporal set of images, we had this kind of good accuracy with that values of threshold. But obviously, when the pixel purity in the fraction of images decreases, obviously your evaluated accuracy also decreases. So you can see here in this graph. So this February 2015 is kind of the monotemporal image, and then the other one is multitemporal as images. And also here, another things to discuss, like this methodology also allows to identify obviously the good validation results for the red mangrove species, and in either cases of monotemporal and multitemporal images. And especially for the black mangrove and white mangrove, we actually found those lower validation results, and obviously that's because of the mixture between them with other classes, because they're black and white. Well, the interesting thing is that about that research was this methodology actually did allow to build land coverage maps, which were for that moment very much realistic in case of monotemporal images, like if you compare multitemporal and monotemporal. And that actually represents the first and fundamental step when you are going to monitor the ecological impacts, especially this kind of fragile, I'd say, fragile mangrove ecosystem. Also, this study will permit you not only to monitor, it's also permit you to manage and how far I remember, like based on this work from my colleagues, that they are claiming that for that time, it was the first time in Cuban archipelago, those smaller islands, this kind of mapping for this kind of ecosystem has really big certain impacts. And obviously, in particular, the analysis of spectral behavior of 3 species led to the important results only in case of separating red mangroves from other mangroves. I think that's the very much particular thing that get off from this research. Thank you very much. That was my small presentation. And if you have any questions, me and my colleagues are here. Anything, we can go.
Thank you very much, Abdul, for this presentation. It's very important to measure and to learn better how the communities interact with the forests and all this stuff. Forgive me, I do not very well the terminology, but I think you understand very well what I mean. Yeah. In Greece, for example, we had this summer a number of wildfires, and now we are looking to set up a methodology, I would say, on how we will manage to monitor the effect of the existence or the absence of forests in the capacity of the country, and how and what the impacts will be in case of such wildfires and the loss of some specific forests. Thank you very much for this presentation. If there are no any questions from the audience, I would like to thank you all for this session, and I hope to see you all in person in the next ICCSA conference, which I heard that will be held in Malaga next year. So thank you all, and see you all again next year. Thank you.
Thank you very much.
Thank you. Thank you.
Thank you. Great. Thank you. Bye.
Bye bye.
Bye.